Hello, everyone, and welcome to the final presentation of the AI for Impact Talent Program. We have a lot of people here in the room and a few with us online, so very welcome. This AI for Impact initiative originated in the end of last year when we found out that we would receive funding from Google Org to work with AI for nonprofits and social entrepreneurs. And the initiative as a whole has some different aspects. We have a responsible AI board, there's networking events, and a hackathon. But today we're going to mainly focus on the talent program. And when we started thinking about what kind of talent program we wanted to do, we figured that we wanted to be able to make some impact, and we wanted to be able to work with several different organizations and have talents work with proof of concepts or with use cases during a shorter time. So let's also share the presentation so I can show you some numbers. We started recruiting in January this year, and the application was open for 3 months. And as you all know, here in the room, we had 2 interviews, one way video interview and then one digital interview. And it was me and Lukas doing them. And I don't think any of you know this, but we actually had 235 applications. And then most of them were people who applied as a team. So it's probably way above 300 individual applications. So that's quite a lot, I would say. And you guys made it. And we are so happy about that. And I think that all the talents that we've had this summer has really had the motivation to work with nonprofits, with social entrepreneurs, to do something that can create a big impact and to help other people. And I think that has really shown in your work and in your projects and in your ambitions. So we are very happy about that.
Yes, and to give a brief background for those of you that are online and for those that will look at the recording afterwards, the Summer Talent Program is these 15 talents that come from university levels and different universities in Sweden, all with some sort of data science, math or computer science, AI profile. And they've been working with 5 nonprofits. And as you mentioned, there were a lot of applications for this. And out of all of these, we picked out 5 that had different needs and different problems that they would like to have solved with the help of these talents and AI technology. So, so what happens then if we take 15 talents, 5 nonprofits, and put them together during 10 weeks? Quite a lot, and we will see the result later now. And the idea of this program was really to create real use cases. And this is just for you talents to remember how you looked in the beginning. See how happy and innocent you were. Yes. And now 10 weeks later, we are here today, and we'll see, all the viewers can see the difference in these 10 weeks here. But also to give a big short introduction to the projects that you will hear about today is Mind, UNICEF, and Reach for Change, the Swedish Sea Rescue Society, and the
Red Cross, right?
The Red Cross, thank you. I can't see the old things on this. And also I would like to say that, are you interested in learning more about this and reading about the project as a whole and the different projects? They are documented on My AI. And you can scan the code here if you like. And also, if you're curious, all of these project results will be communicated and spread via our newsletter, AI for Impact. And also, I recommend you to look into our general newsletter as well if you want to stay up to date with what's happening in the AI world, and especially in Sweden. So Then I would like to invite Lukas, our colleague that's been really helping out with these talents, to introduce all the organizations and the presentations.
Thank you so much for that intro. And yeah, with that being said, we're going to kick off the presentations. And I believe each team are going to have like about 20 minutes of presentations, and then some potential Q&A as well. At the end of each presentation. So do think about your best questions and don't hesitate to ask each other towards the end. But with that being said, I think we're gonna jump straight into it, and we're gonna welcome up the team Reach for Change. So please give them a warm hand.
Yeah, let's get started. So welcome everybody to our final project presentation. My name is Esther. I'm with Andrea, and Robert is joining us online. So we're a group of AI engineers, and today we're going to show our AI-driven application, which is a collaboration with Reach for Change to empower social entrepreneurs. So today's agenda is going to go through a quick introduction of us, an overview of our project, the goals, objectives, our whole architecture, and we're going to do a live demo. And finally, challenges, impacts. And if you have any question, do not hesitate to ask us and we will answer happily. So to get started, just meet the team. I'm Esther and I'm an AI engineer. I have studied in a master's in artificial intelligence in Stockholm University next to Andrea. She also joined me in my studies. And we also have Robert, who is an AI engineer, and he's studying a master's in machine learning in KTH University. If you want to connect with us and ask any questions, here you have our LinkedIn, so don't hesitate to just connect and talk to us.
Yes, I just want to make sure, can everyone hear me good?
Yes.
Okay, well, good afternoon. It's nighttime here in Singapore. So Reach for Change is a nonprofit organization, and they approached us and AI Sweden with the goal of with the problem that social entrepreneurs have with limited research. Social entrepreneurs, they typically have problems regarding social issues, but have a hard time finding substantial evidence for their social issues that they work with. So with this goal, we came up with several objectives for us as the team to solve this problem. Next slide, please. So we had three main objectives. The first primary objective was that we have a simple, user-friendly interface. Second, reliable sourcing for these social entrepreneurs and the research. And thirdly, real-time data retrieval. I'll expand upon these. Many AI products nowadays, they're very intimidating and can be very advanced. It is important with this product for social entrepreneurs that we guide them and nudge them in the right direction so that they don't feel lost. Here we, for example, instead of prompting the social entrepreneur, the end user, to ask their own questions, we suggest questions and queries for them to use. Second, reliable sourcing. ChatGPT and other large language models, until recently, and many of the large language models still lack authoritative sourcing. It is important that these social entrepreneurs have authoritative sources, and in this case, we were given a list of prioritized sources by Reach for Change, such as the World Bank, UN, Eurostat, and other similar organizations. Lastly, and the third feature, real-time data retrieval. We want to have the most up-to-date information. We want to be able to use historical information as well as new information found on the internet. So these three goals, they were not just theoretical, but they formed the whole basis foundation of our application that we built. Next, we will go to the architecture where Andrea will speak.
Yes, so this is the whole architecture of our web application. But before getting into the details of how it's structured and designed, let me just briefly explain what's the term of retrieval augmented generation, because this is mainly the backbone of our backend system. And essentially, this AI technique combines large language models with advanced information retrieval methods in order to extract like the most relevant pieces of information from large collections of documents or data, so that we can respond properly to user queries. And this approach ensures that the generated responses are accurate with fewer hallucination errors and also up to date with like the latest information. Now that we know what RAG is, let's dive into the architecture, which essentially is divided between two parts, the front end and the back end. The front end is the part of the system that where the users see and interact with directly. And it's built using React, JavaScript, HTML, and CSS. And for those familiar with web development, these are like standard tools to like ensure that our platform is both responsive and also easy to navigate. And all of this front end is hosted by an AWS service named Amplify, which not only like provides a secure and a scalable environment on the cloud, but also automates this process of updating the changes that we do, that we make in the application. So every time we make improvements, those changes can be easily integrated and deployed. And we also use AWS Cognito for users' authentication to enable like sign-ins and logins of the users. Then we have the underhood part, also known as the backend, where all the processes and all the application logic run. And it is powered by an AWS service named Lambda function. And essentially this serverless environment runs Python code that processes the user's queries and like orchestrates the whole RAG system. And so when a user enters a query into the system, from the front end, it will be sent to the backend through an API gateway that facilitates the communication between these two parts. And another important thing that I want to mention is that during the retrieval of the relevant information, our RAG system can use two types of vector stores. So first we have the persistent vector store that contains pre-uploaded documents that deem to be relevant. So when a user enters a query, first it will check for relevant information within this vector store. And if it doesn't find anything relevant, then it will perform like a real search on the internet. So in that way, it creates like a temporary vector store to generate like a better response. And at the end, the relevant information is sent to the large language model to generate like a detailed and a contextually relevant response. And this response is also stored in a DynamoDB table, and this response is also sent back to the front end so the user can see it. And if the user also puts some feedback on this response, saying a thumbs up or thumbs down, then it will also be stored in the same table. Additionally, certain admin users can also upload PDFs to the persistent vector store, making this knowledge base better, essentially. So overall, this architecture combines like stored data with real-time searches to generate like accurate and up-to-date responses. And moreover, it's also designed to be scalable and serverless, meaning that it can adjust automatically its resources based on how many people are using the web app. So let's say that more users start using this web application, then it will automatically adapt to handle this increased demand without like any manual intervention or downtime. And this is the whole architecture. Now Esther is going to explain like the demo. It's going to show the demo of the web app.
Yes, so this is a live demo, so hope it works. Let's hope so. So if we go into the web page, what we see first is what she said, it's Cognito. So it's a login, you should create an account and then you just log in. And then we go to our main page. This is our home page. You see that we have our tools and a brief description of each of them. And then you can choose whichever to use. But to guide you guys through all this process, I'm just gonna go first to the About page, which this is a brief description of our application. As you see here, there's a tree. We have followed this tree from Reach for Change, as this is what they do to do their research. So first they have a social issue, and then try to find the root causes of this social issue. And once they have it, they just search for the consequences. So our main app is based on this concept that you need to find the root causes and then the consequences. Also, you have here like everything explained a little bit more detail so you understand it better. So what we did first was to create the root cause analysis. So as you can see, this is really user-friendly and visual. So you just need to introduce your social issue and the geography that you want to search, and you will get an answer. So I'm just gonna just unemployment in Nigeria as an example. And then the LLM is first searching, what we're doing is searching the S3 if there's any storage of the information related to the youth unemployment in Nigeria. If there's no information in our package, then it will go through the Google search and will find the relevant information in the internet. So it's not the fastest, but it's reliable. So that's what we're looking for. So here you have the bullet points of what could be the root causes of this social issue. And it's also with the links of the sources that we have used. So we make sure that it's reliable. As you can see, if I click, then you just have the, yes, here, the web pages with the articles, which should be all reliable, yeah, and academia. And then you can download the PDF and you can even do more research if you're interested in it. And then what you would do is just go to the consequence tracking, because now we have the root, then we want the consequences. And I would just enter the same input. And now it will return with a list or an explanation of what could be the consequences of this youth unemployment in Nigeria. This can be adapted to any social issue that you are looking for. Yes, so here we have all the lists and the list of the sources that it's using. So this is making sure that it's not hallucinated, that the answer is correct. So once we had this, we were like, okay, but what if they want to do more research about the topic? What if they want some other questions? Because this is like really limited. So we also implemented a problem research analysis, which also follows the social issue and the geography structure, but you can ask any questions of your own, or you can have like here a drop down with more questions that are like, that they've given to us. This is from Reach for Change, that they thought this would be nice, but it's the same procedure as the other two. But once we had this, we were like, okay, we found out a problem that most of the end users don't even have any paper or any academia or any data about the research. So using this, if there's no information, it's a little bit useless. So we implemented two new tools, which are the interview scripter and the survey generator. This will perform an interview for you. It will ask all the questions that are supposed to be asked in an interview, and it will suggest some questions that are useful. So I'm just gonna follow the steps. As you see, I've done it like really intuitive, like you don't even need to think it, you just enter all the inputs and it follows. Like you even have here a text. I'm not gonna fill it because I don't have a social issue, but you can easily just copy and fulfill it with your information. This will generate a script that it's gonna guide you through an introduction, a question phase, and an exit phase that you can just go to the people that you think they're interested for this social issue, and then just ask these questions and have your own data started. You have a list, and also you can copy it or you can download it as a PDF, so you can bring it in paper. And if you want to make notes or you want to add more questions, you can just add it there in paper. And now we have the survey generator, which also follows the same structure of the interview scripter. But these questions will be more based for wanting to do a Google form. Like usually, as in like when you want to get some data, you usually create a Google form. So what you do is just to add all the questions. So this will make the question for you. You just need to add it in your Google form, and then you can just send it and get all your data. So it's gonna automate the process. Yes, and here we have, and you can see if it's an open question, a closed question, and what should be introduced in each of them. So it's really easy to just go to the Google form, copy the questions, and just send it. So it makes it way easier. And you can also download this if you like the questions and you want to bring them to an interview. You can just take all these questions and also ask them. And as you can see, we have a thumbs up or thumbs down. This is to get us some feedback if they like the answer, if it was useful. So we also store this in the DynamoDB, as Andrea said. And as to end, we also implemented this easy upload documents. This was to update our bucket with information. So this is restricted to some users, so nobody can access this if they're not a root user. So we make sure that all the files that are updated, they're like from the root users, they know what they're uploading, and this information will be used to answer the questions from the other parts like the root or the consequences. So if you find any information that's useful, you can upload it. It will create the embeddings, and then it will be used to answer the questions. And that's pretty much our main application. Then you just sign out, and that's all you can do here. Yes. No. Okay, thank you. Yeah.
Thank you, Esther, for the fantastic demo. Now I will talk about the challenges faced we had during this project. So the primary problem we probably had during this project was web scraping. The internet has a vast amount of information. However, when you web scrape automatically, we often interfered or came into these problems with bot blocking. This is a common procedure done in the internet because some websites simply don't want bots. We overcame this by using several APIs. Reach for Change had given us a list of organizations which we deemed to be relevant. These organizations included organizations such as World Bank, UN, Eurostat, but unfortunately only a limited selection of these sources had reliable APIs that worked for our use case. Some of these APIs have massive unstructured databases, which have terabytes and terabytes of data. And for our real-time use case, this was not feasible. Some PDFs as well online are massive. They contain hundreds of pages and many megabytes in size. And embedding this in real time is just not feasible for our use case. The second problem is we faced, or one of the larger ones, is latency issues. Personally, I love it when it's real time, like many of these chatbots are nowadays. However, because we wanted to embed things in real time, for our use case, it does have a latency problem. But we did try to employ caching strategies and parallelization during the web scraping to improve this. However, it only improves it by limited amounts. Secondly, cloud deployments. Cloud deployment, none of us had too much experience with cloud, and there's a big difference. I think all the other teams can verify this statement, that deploying a project locally and deploying a project on the cloud is vastly different. We had many authorization issues when having it in the cloud. We tried to integrate it to Google accounts. We even worked with automatically creating Google Forms and signing in with Google, but this was hectic, and in the limited time scope that we had with our little cloud experience, this was not feasible. Lastly, the interface design. None of us have primary web development backgrounds, but despite this hurdle, we managed to overcome this. We have a modern framework, React, used to build the website, and designed this around reach for changes guidance. It was important that the front end of the design, the user interface, is simple and it has very structured tabs, and the queries and questions adapted to the end user. We were always in touch for reach for change regarding how exactly set up these questions, which questions, and which specific services to provide to the user. Next slide. So what is the end benefit and impact of this product? Well, for the social entrepreneurs, this can be used as an authoritative sourcing mechanism to provide evidence and a basis for their social issue and why it needs to be solved. No such tool exists with prioritized sourcing from authoritative sources. This thereby improves data accessibility, democratizing this sort of research process, which nowadays maybe is heavily skewed towards academia or professionals with very high academic backgrounds. This accelerates the research processes and ultimately allows the social entrepreneurs to deliver their social impact faster than they could without such a tool. So yeah, this is the conclusion. We hope that this project, or we believe that this project really aligns with the Reach for Change mission to apply, to amplify social entrepreneurs and help them with the impact that they make to create a real difference in society and real social impact. With this service, we hope to improve this access to authoritative information and provide an interactive tool empowering social entrepreneurs to really deliver this social impact. Thank you very much. We will now have a Q&A session.
Yes, thank you very much for this presentation. Super impressive, and yeah, just amazing to see what you have been able to do in this relatively short time. And yeah, we're going to open up the room for some questions, but before that, I have a question for you. So if you could continue on with this project now, continuing into the fall, what would be the next step in the development phase?
I think, or I believe that we would automate the Google form survey better.
Yeah.
Like we wanted to integrate it, but it's really hard. It's given lots of problems of authorization, basically. So it's not that easy. But I think we would work on that. We would need a little bit more of time, and I think we would get it.
All right.
That's true.
Yeah.
I would like to add in there.
Yeah, go ahead.
Yes, I think there's many things I'm excited about improving with this product. One of the larger things that I would like to improve is sort of the access to more APIs, more data. There were many databases that we were using, I believe, especially databases such as Eurostat, which were massive, had terabytes of data, and navigating these data sets is very difficult when you have to do it in real time. There does exist methods to sort of automatically generate SQL queries, and this I was very fascinated in. I was also very fascinated in employing sort of multi-agent techniques to verify the contents internally. But yeah, we spoke to some industry professionals, and we decided to limit the scope of the project to something that was very realistic and wouldn't overwhelm us.
I think that was a wise decision of you. Of course, there are many things to explore, but the time is limited over just one short summer. I do believe we have time for one last question if there's anyone in the room that would like to ask. If not, we give them a big applause once again. And with that said, we're gonna welcome the next team, which is actually now, let me see that I say the right thing, UNICEF. So warm welcome, team UNICEF, and give them a warm hand.
All right, cool. Hello, everyone. We are the team that worked with UNICEF, and we will present to you today how we harnessed AI to understand retained donors. So let's get started. What are we doing? We first introduce ourselves, then give you some context, talk about the data we have used, talk then about our AI solutions. So the model for data churn is the first, and then we will also present you an AI assistant. We will tell you how we integrated these solutions, show you a live demo, point out some limitations and lessons learned and future directions we would go in. And then lastly, we will have a conclusion. So who are we? The three of us, Jonathan is online. He's in the US right now. We have Rosa Emilia next to me, and me, I'm Misha. All of us have backgrounds in computer science, machine learning, and data science. So that's about us. Let me give you some context of what we are going to talk about. Basically, UNICEF has seen a decrease of new donors and increase of donor cancellations. So both is not really a good mix. And then we also have seen that UNICEF has seen, not we, that traditional recruitment channels are losing their effectiveness. And when we look into research, we see that retaining donors is up to 5 times cheaper than acquiring new ones. So retaining, keeping the donors donating for you is way more efficient than trying to acquire new ones. Like many other companies, UNICEF is starting or is in their process of their data journey, trying to improve their analytics and data management. And that is where we, or AI Sweden, comes into play, where we are trying to explore and implement different AI-driven solutions to help UNICEF understand their donor data. And we are particularly aiming in this use case to retain or to identify why people are stopping donating, why people are churning.
Now, looking into the data that we work with, there were 3 main sources that were provided by UNICEF to us, and there were 2 external ones that we acquired. As you can see on the screen, the ones in red are the ones that UNICEF provided us with. So we have roll-up summaries, which are personal information about the donors and what have been their first and last actions. We also have email interactions. However, this only is available for active donors, so donors that are active opening emails and so on. And it only spans 6 months. And we also have the payment history. And for the payment history, we have how much a donor has donated and if this donation has been a one-time donation or a recurrent donation. We decided to include as well the salary of the donors by scraping the web and using their postal codes to get it. And then we also included inflation rates, which we have a granularity of per month, and then we only focus on Sweden. Now we face some challenges with the data that I'm going to go over now. Well, first of all, regarding the payment history, even though we have time series, it really lacks the causes of why or where the donors are donating to. Then moving to the roll-up summaries, well, the information about the donors is excessively summarized, so we don't know throughout the whole process of the donors where or what they have donated to. We only know the first and the last. And then about their email interactions, the data is also limited. We only have a 6 months span, and it does not contain all of the donor base. So we face some challenges with the data. And recognizing these limitations was an important part of our project because we needed to understand the limitations in order to develop and provide solutions, right? So we came up with the idea of implementing 2 complementary solutions to assist UNICEF to understand and address this challenge of donor churn. The first one The first solution looks into a predictive model. So we want to predict when a donor is going to churn. And we hope that with this model, they can run it and then get monthly predictions, and then they get targeted. These donors are more likely to churn. And then the second solution is an AI assistant, as we mentioned, or a chatbot that aims to translate natural language queries into SQL and then provide UNICEF with a tool to do data analytics in an easier way.
So let's dive deeper into the donor churn prediction model. We basically start with two types of data. We have the static data stream at the top and the time series data stream here in red marked. First, we started by cleaning up the data sets a bit and removing inconsistencies. Then we looked into feature engineering. So adding or calculating new features based on the information we have to get even more insights about the data. Then the step of merging both data streams come into play, and we generate a data set that we can use to train on, which we then trained on models. So we went through more traditional models like the decision tree, random forest, KNN, support vector machines, but also more advanced models like CatBoost and neural networks and XGBoost. In the end, we went with an XGBoost because the model complexity and the time for inferences is still well balanced. So we went with that, and also the accuracy that we achieved was quite good. Then we trained these, and lastly, we looked into insights and explainability. More about that in a bit. First, how do we generate samples? What did we do with the data? In the first step, we combined them into a common structure. So we took the time series data and the static data and created this combination. Very easy and simple, right? So let's try to confuse you a bit. After we have this basically done, we have to align the data in a smart way to make predictions on them. So what we did is we took 3 years and shifted all of the donors to the right and looked if they are churning or not. We do this because we don't care if someone churned in January, March, May, June. We care about the behavior pattern, about what led up to that effect. So we all put them aligned here on the right axis and basically have here marked if they are churned or not. We look into a prediction window of 3 months. We tested this, and these are the values that were the most successful ones to predict. So if someone is going to churn in the next 3 months, and we take transaction history data of the past 6 months. So we have an overall sliding window of 9 months, and then we can take this window and roll back in time to create more and more samples. One thing to note, there's one person here, for example, at the bottom who has less than 9 months of transaction data. So these people, for example, we would have to exclude. These are the results. So you can see for non-churners, trying to predict non-churners, we got very good results. Our model was good at identifying them. For predicting churners, however, it doesn't look that good anymore. We overall, though, have an accuracy of 97%, but since we want to predict churners, we are way more interested in that. And out of 10 classified churners, there was 1 person who would actually churn. This accuracy, or like this overall statistic, is not ideal. We would have hoped to have a higher score on that. But still, since the cost of approaching, let's say, these 10 people is quite low, sending an SMS or an email, if that would lead to preventing 1 person of not churning, we still believe that this has a positive impact and can be used for UNICEF. And then since UNICEF is also very interested in not only having these values and knowing who to contact, they also want to know why are these people churning, what is the pattern, what are red flags. We looked into feature importances and force plots like the SHAP values. But yeah, I think that is more interesting for UNICEF.
Cool, thank you. I'm gonna talk a bit now about our second solution, which is the AI assistant or chatbot, as we name it. which basically allows users or employees from UNICEF without an SQL knowledge to gain insights into their donor base by asking natural language questions. There are three important things that we had to consider when implementing this, which are basically data privacy concerns, then how are the users going to interact with this system, or which sort of questions they're going to ask, and lastly, which functionalities we wanted to have in the project and how should we design it as well. To address the first concern, which was the data privacy, well, we all know here that having personal identifiable information on LLMs is like a big red flag, right? The data can leak, and this is not something that we could do or that UNICEF would be happy to do. So to address this, we implemented, or we fine-tuned 2 LLMs. The first one is only focused on generating SQL queries, and it does it by having a question and then knowing the structure of the data set or the database. So it doesn't have the actual data, and it generates an SQL answer. Then the second LLM, which is the one in charge of, answering the question, it just takes as an input anonymized user data, which is a subset of the entirety of the data set. So it doesn't take all of the data, and it just, with this anonymized data, sort of writes a nice human readable answer that we then output to the user. So that's how we deal with the privacy concerns. Then regarding the user interactions, as we said, we wanted to provide an interface for the users to ask just natural language questions. So we thought, and we also talked with UNICEF, what were the sort of questions that they would be interested in asking. And we then went and fine-tuned the models to be able to do it. So questions that our solution is able to answer are, for example, in the lines of, is a donor more likely to churn during their first 3 months? Misha is going to show more about that later. And then lastly, just about some design or functionalities, we are using GPT 3.5 Turbo from OpenAI for our models. And then we're also keeping track of the history to improve the quality of the answers. But we only do it up to a certain point, which is when we reach the maximum number of tokens of the LLMs, and then we remove the history. Now, about the flow of how the LLMs are connected and how the whole user experiences inputting an answer and inputting a question and getting an answer. The user starts by first inputting a question, as we can see here. Then we pass that to the first LLM, which generates an SQL query. We execute that in our backend, and we extract from our MySQL database the answer. Then we check how large is this answer. If the answer is very big because there was a lot of data, we directly output it to the user in a nice way that you're going to see. But then if the answer is not too big, we anonymize the data and we provide it to the second LLM, which gets this smaller subset of the data, anonymized, and the question, and then generates a nice human readable answer.
Yes, can everybody hear me?
Yes.
Yes, perfect. So this is our system structure for how UNICEF is supposed to interact with the web page that we have built. So they interact with the React frontend deployed on an AWS instance, EC2. Currently, it only has 1 GB of RAM, which is the limiting factor of how usable this application is for the moment. We intend to integrate some load balancing and hopefully increase the size of that in the future. But the React is based on Material UI components that are pre-built. And then we use some Chart.js components as well for the charts where we in the explainability page. Then we additionally use one component for the chatbot NLooks to integrate the chatbot into our web page. Then in the backend, we have a Django web page, which is the spider in the net talking to the different parts. This is where the data is uploaded to, and Django then writes it to the MySQL database that we have locally. Then additionally, Django talks to XGBoost, which is the model that we chose, which we have trained to get the predictions for each user. Then Django also does the communications to OpenAI to support the 2 LLMs in our chatbot that we have developed. So this is the whole structure, and it's all deployed on the AWS instance currently. Yes.
Amazing. So now that you have seen that, let me real quick move forward. So this is our application. This is the website that, or the AWS instance that was provided from UNICEF for us, which is functionally working. For demonstration, however, we will show you that same application running on my local computer. So UNICEF can log in with a very secure username and password, admin, that they can choose themselves. And then the first step is to upload data. So this roll-up summary, here you'll find information about what has to be included, such the upload works functionally perfectly fine. Once that is done, the data gets stored in our database and the user can upload the next data, the opportunities, the payment history. Same process, you have to upload the data, and once the opportunities are uploaded, once the history of payments are stored, the model gets triggered and calculates the predictions for each donor of how likely that person is going to churn using the latest opportunities. That information then gets displayed here. We have our prediction table, which is the main component of this page with all of the information. We can go through these users here. We can filter, sort, not filter, we can sort based on the values and yeah, get also some information about what are all of these columns, what is their meaning. Then this functionality is to filter. So for example, we can filter on the probability to churn. We want to have, let's say, a probability to churn higher than 0.9. So the people that are most likely to churn. Yeah. So yes, it took a bit, sorry. I got a bit confused because here at the bottom, this number now should match this. And after that, we can also add more filters. So we can stack filters on top of each other and apply them. We can select multiple columns, display them and deselect them. We can, if the user found some useful information, extract that as a CSV. And this will then apply the filters and only extract the people that you currently chose with all of the columns. And here at the bottom, we find a summary graph, so a pie chart of who's most likely to churn and not, the same statistics and a probability distribution graphs. So here 0.9, a very high, the high value means high likelihood to churn, low likelihood to churn. And you can also play around with this threshold. So for example, if we lower the threshold from 0.9 to 0.5, we get more people that are more likely to churn automatically updated. And to give a bit more understanding for someone that doesn't know machine learning and AI, we have an explainability page that first talks about how can AI and machine learning be useful in this field that we are researching in, what model has been used and how does the model work. We also talk then about the features, which features we created and the additional resources that we used to create the features. We talk about the data, what you have been already seen, so you're an expert on that now. We talk about the model performance, how bad and good it performed, how a model made the decision, what features were very important. And lastly, we also look into how each instance got predicted. So for example, which features, high and low values, influence the model's prediction. All of that is one part, and then we have our chatbot as the next part, which enables you to ask questions about the database. For example, here we have some conversation starters. The first, for example, if a donor requests to be not contacted, does that correlate with a higher likelihood to churn? And then we get the answer here. And if you are curious of how this answer got calculated, you can click this information icon and see the SQL code that got executed in the background. So if you know SQL, you can check that. I know SQL, but this is also a bit cryptic to me, so not completely understandable without any information, additional information. The next question, for example, is targeting a specific segment of the donors. So we can apply filters like older than this and having more of these features. And then we see that we get all of the users displayed, and we have here a limit of 100 people to not have too many people in one table. But then if you decide to get all of these people that are applied to this filter, you can export this as a CSV, and then this gets exported. You don't see the download icon popping up, but I got it open and it's downloaded. So that is basically it. This is the live demo. We covered everything. Everything is working wonderful, right? We are done. That is half of the truth, because there are also some limitations. There we go, there they are. So for example, the prediction model that we are using, we discovered last week that we have some inconsistencies in how the features are created and how we align the time series and not time series data. Jonathan already mentioned the server performance. We showed you our local version because everything is way faster in the computing time. That is a limitation. The AWS instance doesn't have HTTPS yet. We don't have the admin rights to change that. So that is a security concern. And lastly, we also don't have any visualization of the historical user data, the transactions. So that is another thing that we would like to add.
Yes, and for future directions, we would like to improve the model. We realized during the testing of this last week, we realized that there were some bugs in the pipeline for the data that we created, so that one field was missing and was incorrectly calculated. Then again, for the server, we would like to talk to UNICEF about the possibilities of increasing the data power of that, and especially the RAM, since when uploading a lot of donors, it takes quite a lot of RAM. Then for the data, we would like to implement, so currently we have manually integrated the inflation rates for the past 5 years. We would like to write a script to integrate that every month, so that it manually pulls that from SCB website. And then we would like to write some documentation as well. Currently, there isn't that much documentation since we were very stressed towards the end of the project. Then that's one aspect we would like to improve on as well. Yes, and then for lessons learned, we realized that it was very important to talk to the right people at the right time. Yes, and then that persistence pays off. In the beginning, we didn't have the time series data as we wanted, but we persisted and proved to UNICEF that it was valuable for them as well to give us that. And finally, halfway through the project, we got access to the time series data as well. So persistence pays off. And then adaptability is key. We have had to adapt our model and everything we have done every step of the way through the process. We had one product in mind in the beginning, and now here we are at the end of the project with something slightly different. So adaptability and having to change the product as we go, that's one lesson that we learned. Yes.
Cool. So now to wrap up, our work with UNICEF address an important issue for them, which is how to identify and reduce donor churn, or donors at risk of churning. And over the course of this presentation and of our internship, we have demonstrated or show how AI can be used and what the potential of it is to be used in this use case and to help UNICEF and other nonprofits which are also facing similar issues. First, we show that AI can be used to help with predictive analytics. So by identifying donors who are at risk of churning and sort of alerting the nonprofit or UNICEF so that they can do targeted interventions. We built a model, and while it is not perfect, we believe and we have demonstrated that it works up to a certain point, and it could be beneficial for UNICEF to use it. Second, we have also shown how AI can be used in making data more accessible. There are many people at UNICEF, we believe, that could benefit from playing around with the data and from getting insights into the many different metrics and just ideas about why people are churning and so on. So we have shown how AI can be used in this case to translate natural language to SQL and allow for this. So in short, just to now finally conclude, we believe that AI can be a valuable tool, not only for UNICEF, but also for many other nonprofits and organizations to overcome some of their challenges that they're facing. And we are very happy to have contributed in this project with AI Sweden and with UNICEF to make it possible. And we're very looking forward to continue working on the extra 5 days that we have for the potential impact that is going to have. Thank you. Yeah.
Thank you very much for a super impressive presentation. I think that was very fascinating. And I love how your application really lowered the threshold of people who can interact with the SQL database, for example. But I want to start with asking a question. So if you think about from the perspective of really any organization that is interested in doing some sort of churn prediction, what would be your advice in terms of how they save or work with data? If you have any top of your mind advice for such an organization.
Yeah, I can go. I think my advice would be for non-profits or a company that tries to deal with that, record as much data as possible and save it in ideally one common base. So what we, for example, saw that because we had 2 data streams, in the end, we tried to combine them, which led to data inconsistencies. So that was a big issue that limited us. And it's not an easy task. I also don't know the exact solution of how to do it, but I think that was the foundation that has to be there and needs to be in a good way to make use of any AI solutions.
And okay, thank you for that answer. And I was also curious, did you have time to get any sort of feedback or response from people working with data from UNICEF, or was this too short of a time frame to get that kind of feedback?
We will have the final presentation with UNICEF next week, so I hope to get more information about that as well. So far, what we heard is that they like the possibility to ask questions, and also that some branch in UNICEF, the marketing group, would like to explore this opportunity. But yeah, I don't have an answer.
All right, let's open up to the room. If there's any question, feel free to ask it now. Yes?
In terms of
1 second.
I'm just going to give you a mic.
There you go.
I guess I also want to celebrate some insights that I'm seeing, and I'm wondering if maybe your client recognized it too. But did you guys have any recognition for the fact that the churn rate was so small and it created difficulties for you, but also that maybe that is just a good conclusion for your client? Or was there any, I guess, silver lining there in terms of the predictability of who's going to churn is difficult because the, I guess, percentage is so small already?
Yeah, we believe from the testing that we've done, there's no guarantee that is correct, but we believe that the data we have used has a little true variance. So basically, all the transactions are quite similar, even if someone churns or not. So we believe that the model struggled to really identify a common pattern. We tried to work with the imbalance of churners and non-churners by looking into different weighted losses and also oversampling techniques. But all of that did not have the promising results as we would have hoped to really have a model that is very good at predicting churn, which was the main goal and challenge. But yeah, even though that this performance was not as good, maybe due to all of these reasons, we still think that it is better than nothing. And if it can help to prevent or like that, to contact maybe 300, 600 people a month, and maybe out of these 30, 50 would have churned. And maybe then out of these 30, 50, only 10 or 20 people churn, it would be, I think, in our eyes, useful to have.
Super cool. Any final question? If not, we thank you so much once again and give them a warm applause.
All right, let's go. All right, thank you everyone. So we are the team behind the Red Cross project, where we have delivered a mobile application that we're calling the Red Cross Assistant. And for those who haven't met us previously, we are 3 industrial engineering students studying in Linköping, taking a master's degree towards machine learning. And I'm Jacob.
My name is Hannah.
And my name is Axel. Great. And today we are going to show you our mobile application, the Red Cross Assistant. We will walk you through the process, how it started out with our mentor Robin up in Umeå, having a great idea, and how it then has shaped throughout the progress of our project to landing in this end product today that we have with us. So starting with the agenda, Axel.
Yeah, so first we will go through some scope and background, and then we will come through to our 3 identified use cases from the background. We will present the demo, but we have a pre-recorded one for simplicity. Then we'll do some technical description and finish up with some further potential improvements.
Yes, so starting with the scope and background. On the refugee side, they need a tool to be able to communicate with Swedish people when they come to Sweden. And since they don't know any Swedish or English, they need a translation tool. They also need a tool to help them get to know the Swedish society. They are going to have questions about the society they live in, work, and the migration process. Yes. And on the Red Cross perspective, they also need a communication tool since they don't know any Ukrainian. And they also need an easy-to-use translation tool, since many of the Red Cross volunteers are elder people that don't have so much technical knowledge. Additionally, they need a tool to help them analyze these conversations. It is hard to remember what everyone has said in all the conversations, so they need help with doing the statistics for the conversations.
So based on this background, we identified 3 use cases. First of all, to the left is the translation tool, which will then work as the translator. Second of all is the community guide, which will be a digital assistant for the migrants to answer questions about the society in Sweden. And then thirdly, the admin analysis tool, which is for the Red Cross managers or workers to ask questions about the conversations and to improve the operations. So firstly, the translation tool. This will facilitate the communication then, and it's a speech-to-speech or speech-to-text functionality. You can choose between multiple languages, and when you have chosen 2, you don't need to decide which one is going to talk, because our app will identify the language spoken. And this comes with a chat-like user interface with the toggling functionality so that you're able to scroll through the conversation and see previous talks. And you can display everything in both languages chosen.
Yes, thank you for that. And then the second use case is a community guide, where essentially we have a digital assistant for the migrants to ask questions about the new society and community that they have joined when coming to Sweden. It comes with an interface where you can interact both with text and with speech. So you can insert your question either by writing it in and typing, or you can talk it in. So that is speech and text functionality. And then the output, the answer will also pop up on the screen in a message format, which is text format, but also come out as a playback in audio format. And the language model that handles this question and gives the answer is prompted by us with ethical guidelines that we have taken from the Red Cross, with documentation from their onboarding process and so on, to make the description to the language model better associated with the context it's operating with vulnerable people and migrants. And the user interface here is, for simplicity, very similar to one that we're using in the translator use case. So it also has a toggling functionality and a chat-like user interface. And the toggling functionality is super important here because when a Ukrainian migrant asks a question and get an answer, if they want to take this forward and talk with an actual physical volunteer that doesn't speak Ukrainian, the volunteer can easily toggle language to Swedish so they can start a conversation about the output that were taken from the community guide.
Yes, moving on to the admin analysis. It has two functionalities. The first one is a chatbot that utilizes RAG to be able to ask questions about the conversations. And the second one is a chart that shows statistics over the most popular topics that is talked about in the conversations. And the migrants will be able to give consent or not give consent in the translator tool if they want their data to be stored.
And now it's demo time, so let's hope the sound works.
Yeah. And for simplicity here, this is a video instead of how we've done on previous presentations. You that were there when we're standing and talking in Swedish, but we have the presentation in English. It gets very messy, so we hope this is more efficient for everyone to understand what's going on.
So first in the app, you need the login page, and this is where you will log in with your Red Cross credentials. So let's see if there's sound.
No sound, right?
Yeah. Yeah.
So.
And you log in with a single sign-on, which is only used for Red Cross emails.
Yes, and this is the start screen. And here you can see some details of the translator tool. So you can read about the tool. So this is the start screen. And here's some details about the community guide.
Yes, and from here we can also go into the translation tool, which we see here, and then going into the community guide, similar interface. And then lastly, the third use case with the admin analysis view, where you can ask questions as an admin, but also here look at the graph with popular topics that is received from the conversations, where we can analyze conversations and the volunteers can simply see what's talked about. Also, look at the dates here. We can simply set in daily here to see the conversations from this day. Changing here, the graph automatically updates, and we can see here today what's been talked about. Notice here how it's on a 3 in accommodation here in the graph. And we're going back into the translation and we'll try the translation too.
Yes, and here we can see that the default languages are Swedish and Ukrainian.
Välkommen till Sverige. Jag hoppas att resan hit gick bra. Jag förstår att situationen kan vara överväldigande just nu. Har du någonstans att bo? Eller behöver du hjälp med att hitta ett tillfälligt boende? Vi har resurser som kan hjälpa dig att få en trygg plats att stanna på. Om du behöver hjälp med något annat, tveka inte att säga till. Vi är här för att stödja dig på alla sätt vi kan.
Ласкаво просимо в Швецію. Сподіваюся, що подорож сюди пройшла успішно. Ситуація може бути пригнічувальною в даний момент. Іншими питаннями не соромтеся повідомити. Ми тут, щоб підтримати вас.
And here you can see the toggling functionality too. So
Щиро дякую за ваш
now Hannah
ласкавий
speaks
прийом.
Ukrainian.
Подорож була довгою, я втомився і не знаю, що зараз відбувається. Мені знаючи,
And as
що
she
тут
speaks,
є
it's
підтримка.
transcribed into her language here, which is
Tack så mycket för ert vänliga mottagande. Resan och var trevlig.
Students to press
Jag är
stops,
trött
the
och
audio will
vet
come
inte
out
vad
in
som händer
Swedish,
just
and
nu.
also the toggling in the
Och
message
detta
will help
oroar mig
to
lite.
change to
Om du
Swedish.
kan hjälpa mig hitta
And
boende.
if you want to go back to Ukrainian,
Det
you can
kommer
easily
att vara
tap
en
to
stor
toggle again.
förbättring.
Yeah.
Jag är tacksam för all hjälp ni har gett. Om du hjälper mig att hitta boende skulle det vara en enorm förbättring.
And to reset the conversation and go back to the starting mode, you simply press the reset button, which we do here. And I think I want to play around a little bit with the languages now. So I'm, for instance, taking English, and the consent instructions as well as the user instructions will follow the chosen languages so that everyone can understand. And try Spanish and German to our friends in the audience here. And I think I feel like talking some Spanish too, so let's go.
Buenas noches, Carlos. Yo quiero beber agua y cerveza y bailar contigo esta noche.
Guten Abend, Carlos. Ich möchte Wasser und Bier trinken und heute Nacht mit dir tanzen.
Ah, caliente, caliente, caliente. Muchas gracias.
Oh, heiß, heiß, heiß. Vielen Dank.
Yeah, so as you can see, it can detect my perfect time.
Vilka är de bästa
Yes, and this
fiskeställena
is the
i Umeå?
community guidance. And now asking what fishing places is the best in Umeå.
I Umeå hittar du många bra fiskeställen. Umeälven är populär bland sportfiskare. Där kan du fiska lax
And
och
the answer is
havsöring. Även vid
instructing her to the best fishing places.
Yeah.
And here you can type in the question as well. And
Utöver
I just
Umeälven och Nydala sjön
yes,
som jag
because
nämnde
I
tidigare
want more
finns det också
information.
andra mindre sjöar
So,
och vattendrag
yeah, the,
runt om i Umeå för fiske.
language
Stora och
model
Lilla
knows what I
Bygdeträsket
asked
samt
for.
Angsjön är några av dem. För mer specifik information om fisken och
Also
vilka
toggling
regler som
between Ukrainian
gäller
and
kan du
Swedish
besöka
and the message bubbles, so that the volunteers can look what's been said. And now looking into the admin screen, we want to look at the graph here, updating that one, and we can see that accommodation pops up to 4, because that was what Hannah was talking about.
And then we will try to ask a question too about accommodation, apparently. So the question is, does it seem like people are missing accommodation today? And then the answer will pop up based on the conversational data that we just had. So the answer is that it seems that people are missing accommodation today based on the conversations, and people express worriedness and fear about it.
So, today is the day of the final presentations of the project. How does the team feel about the project coming to an end?
Så idag är det dagen för de slutliga presentationerna av projektet. Hur känner teamet inför att projektet närmar sig sitt slut?
Det känns väldigt roligt att få visa upp vad vi har åstadkommit under den här sommaren, och vi är även spända på att se vart det här projektet tar vägen i framtiden hos Röda Korset. Det finns en stor potential.
It feels very exciting to showcase what we have accomplished during this summer. And we are also excited to see where this project will go from here. The future of the Red Cross, there is great potential.
Samtidigt är vi väldigt tacksamma över att vi fick möjligheten att utföra projektet och vara med i talangprogrammet. Stort tack till alla på AI Sweden och de andra 4 teamen. Ni är superduktiga allihopa och varit superkul att följa era projekt och lära känna er.
At the same time, we are very grateful that we had the opportunity to carry out the project and be part of the talent show. Many thanks to everyone at AI Sweden and the other 4 teams. You are all super talented. It has been super fun to follow your project and get to know you.
So great. So that leaves us with the demo, right?
Yeah.
So now we'll get into how this actually works. Moving on in the presentation.
Yes, so now we're moving on to the technical description.
Yes. So to make this as understandable as possible, even for those here that not have a specific technical background and don't know much about AI models, we will start by simply telling you a little bit about the user journey that you're experiencing within our application. So both for the translation and for the community guidance, we divide this into 3 different steps. The first step being simply to log in and to consent to the data storage, but also selecting in the translator which languages you want to use. And then starting either in the translator, starting a talking session and talking in on your selected language, or in the community guidance, either talking your question or writing in a question. After that, in the translator, for instance, you press stop, and immediately the messages will display on the screen, but also there will be a playback quite quickly. And what we want to look at right now is what actually happens between those stages of the user start speaking and the output getting sent out to the screen, but also with a playback in audio. So we're going to dive into this. So in the translator screen, as soon as the user starts speaking, we will continuously start doing stuff under the hood. So every 7 seconds, we will divide an audio file and take that away and start a new recording instead. And the audio file that we simply took out, we will do some cleaning with that audio file. We will check if it's silent. If it's been silent during those 7-second session, we will discard that recording. And if the recording is too short for being analyzed, we will also discard and delete that audio file. But if the audio file goes through this process and is okay, we will send it forward to our first AI model, which is the Whisper model. And then an audio file will get sent into this AI model, which simply takes the audio file and transcribes it into a text file. And in this process as well, we will detect the language that's been spoken. Because remember that Axel mentioned that you don't have to set whether you start with one language or another. That is something we detect and do the translation after that and write it out on the screen. And also, we have the Whisper prompted with previous sentences to improve the accuracy when transcribing. So after this, the transcription will get sent into our next model, which is the GPT model, language model, where the translation essentially happens. And simultaneously, as this happens, we will get out the translated text and the transcription and send that to the messages on the screen. So now output will start appearing on the screen as the speaker is still speaking, so they can see what they've said. And the translated text gets sent into our final model, which is a text-to-speech model, where the translated text gets transformed into an audio file. And the audio file then gets stored temporarily in a blob storage, because remember, we don't want the playback to start yet, since the user haven't pressed the stop button yet. And also remember that since this happens simultaneously, that we create new audio files and send them to our AI models, we will end up with a lot of files now in our blob storage. So as soon as the user presses the stop button in the translator, we will go in and retrieve those audio files quickly from the blob storage and start playing the playback. That is how we come up with the solution for the user. It seems like the translation goes super fast, but really it's not super fast. It's just that we start doing it a little bit earlier than the user presses the stop button. So when the stop button is pressed, we will have a playback immediately. And then for the community guide, Hannah.
Yes, the process for the community guide is pretty similar, but we have highlighted the differences here. So the main difference is that here you can type in your question as well as speak in your question. And we don't split up the audio files every 7 seconds because you need to have the whole question in order for the GPT model to answer it. So when the question comes to the GPT model, it both answers the question and translates both the question and the answer to both Ukrainian and Swedish to enable the toggle functionality. And additionally, the GPT is prompted with previous questions and answers to be able to ask follow-up questions.
Okay, so moving on to the final tool, the admin analysis. This is the RAG, the RAG part. So it's two parts. It's first data storing and then data retrieving. And for the storing, we start that each talk gets translated to Swedish. And if I'm doing German and Spanish, I will still translate that to Swedish because we need to store everything in Swedish. Then we take this Swedish talk and vectorize it through the OpenAI embeddings. But we keep the semantics and turn it into a 1,536 dimensional vector. And all these vectors get stored in our database, which is a MongoDB, where we keep the vector together with the text. So this is happening every time we talk. And from the front-end user side, Robin or someone else asks a question and we'll get an answer. As we saw before, does it seem like people are missing accommodation today? And the answer gets popped up. But before that, we do the same. We vectorize the question through the OpenAI embeddings. And then we perform a Cosin similarity search between the question and all of our vectors in our database. We retrieve the most similar and relevant documents, which we put through together with the question to the OpenAI large language model GPT with an instruction saying, answer this question based on a provided context. And then the answer pops out.
Yes, moving on to the technical architecture. In the front end, we use Expo, and we have downloaded, and we have built an APK file that is downloadable on Android devices. And in the back end, we use Azure. So we have our server code running on app services on Azure, and we have continuous deployments through GitHub Actions. And for the data storage, we use Azure Blob Storage for the audio files and Azure Cosmos DB, MongoDB for the vectorized data.
Yes, and even though we think our application is very cool and it's being used right now in the UMI organization, it's still important to emphasize that the only reason for us calling this an end product is because the project comes to an end. There are still various improvements that can be done within this application. And starting off with the RAG, we would like to be able to ask questions for the admins that are global questions and are about the whole data set. And that could, for example, be like, what are the most common problem within the organization or for the migrants? That includes the whole data set, and with a baseline RAG, that is not possible to answer those kind of questions. So there we would have to look into graph RAG or using a clustering algorithm as well. And we haven't had time to do that. And also it's quite difficult because our data set changes every time a new conversation pops up. So that means we would have to do another graph or a new clustering every time. So that could be something to look into in the future. And also the similarity scoring for the keywords appearing in this graph. It hasn't been tested enough to say that this is the accurate threshold that we're using. So we don't really know if it's optimal or not. We have to test it in the organization and see if that's a good threshold to use.
Yes, and for the community guide, we have identified that using web scraping would improve the answers a lot. If the language model could search on Google, they would be able to answer local questions like opening hours and questions like that. Or if we would vectorize some documents with information about common questions that the refugees has. It would also improve the answers.
And code-wise, we haven't done so much testing yet. So we don't really know the values of like determining the length of the audio files that we cut. So right now it's 7 seconds, but maybe it would be better with 5 or 10. We haven't really tried that out. So that's something to look into. Or look into other models which are transcribing real time as it talks. Then also the silence detection, it's the same thing. We only use it right here in the office. So our decibel level is good for that. but maybe in a busy environment where the refugees and the volunteers are talking loud, we just want to focus on the conversation between the two people. So we need to look into that too. So that's also future improvements.
Yes. So to wrap this presentation up, we have delivered a mobile application serving 3 different use cases that are very helpful in the Red Cross organization. We have a translation tool and a community guide that serves with a user interface that is chat-like and very easy to use. And also in the community guide, the migrants can ask questions and get more knowledge in a new way. And in the admin analysis, we let the volunteer get the opportunity to very simply see the statistics from the organization. What is the main problems and topics right now? And you can ask direct questions targeting those topics. So with that being said, there are still further improvements that can be considered, and we are very eager to see what the Red Cross will come up with using this mobile application and what they would want to improve in the future. But that's it for us today. Thank you. Thank you very much.
All right, thank you so much for a really impressive presentation. Super cool to see, and super nice to see the demo as well. Yeah, I want to maybe kick off by asking you, Robin, a question, if that's fine. So I just was curious, like, do you have any main takeaway after these weeks and having collaborated with our talents here?
Well, I'm first of all, I'm super impressed by the team and like also the organization from AI Sweden, how you managed to get this project through. We had to cut a lot of problems away. We had to like scale down stuff a lot. I think our communication was excellent, even though we only like communicated online. So to have this like app actually working and on my phone, so I can try it in our daily work, is totally amazing. And I'm like, it's almost an unreal feeling that we made it and that the app is actually quite complete.
Thank you so much, and thank you so much for your enthusiasm in this project, Robin. Hello, Jonas. Do you have a question? Feel free to ask it.
Hi everyone. Yes, I think I could have a 3-hour session of questions regarding this project. I understand you have a lot of things to do in a very short period of time, but I'll try to squeeze it down to a few questions. When it comes to Whisper, how was it? Is that hosted in the Azure environment?
Yes, it is.
But yeah, it's hosted in Azure environment, but I think that the Azure are doing API calls to OpenAI too, but I don't really know.
Yeah.
So that's, I guess, it's that has to do with how the data is traveling and so on. But so then you save audio. I guess you're not saving it, you're deleting it after the conversation, I hope.
Yes, exactly. We do.
Yeah.
Exactly.
Good. And when it comes to the Whisper part, do you make sure that you always use the large, small, or medium model, or do you have like a way to back off and use a smaller one to make it faster? Or there's so many different versions of Whisper out there. There's also old and a new version, and then the small, medium, large, and then there's quantized versions of that.
Yeah. So I think that's one thing for the improvement side as well with this project, because we've only used the same Whisper model throughout the whole project. And as we mentioned as well, like further improvements, maybe we should look into even using other types of models, using like real-time transcription and stuff like that. So that would definitely be one thing to look into. And as you mentioned as well, maybe depending on how big the input data is, maybe we should use different models depending on that as well. So that is definitely one thing to consider for the future, I think.
Can I? Yeah, because it's like one basic question is that to do speech-to-speech translation, you would use something like a seamless M4T, which is actually handles everything without going to text. So it would actually push it from audio to audio. And that would make it a lot faster, but it's a very big model and so on. And it's a Facebook model, so I don't know if it's actually hosted or even do API calls from the Azure environment. Have you considered using a speech-to-speech model? Or do you actually want the text as well so that you can do other stuff with it? And
I would say at the beginning we were like looking into different models, but we didn't find any like easy to use yeah, we went with this side instead because we wanted the text from the beginning too, and then maybe with a speech-to-speech model you can extract the text too. We haven't really looked into that.
Yeah.
So I would say like deciding the models were not the major part of our product or project. Like we were mostly trying to put everything together, and then which kind of models we used. That's also something to look into.
Yeah, and it was also one thing about not really having the resources in the first kind of weeks to just decide on different models from Azure, and we got access to Azure like 5 weeks into the program or something. So we started out with our own private keys, and then it was just simpler starting out with OpenAI because we already had the keys there. So we just started out there, but yeah.
Yes, and we wanted a text to be able to show it on the screen.
when it comes to Whisper, then do you use so you use only the Whisper part of identifying which language it is?
Actually, we're detecting through a library called Lang Detect.
Yeah.
So
okay, but then you use it on the text, not the speech.
Yeah, we use it on the text. Yeah,
exactly.
Yeah.
But so it's a very
so
good
it's
detail
already
there.
so it's already doing that.
Not, yeah, because it's actually not a thing that happens in Whisper. It happens between those stages, but within the PowerPoint, we just set it there because we don't want to have like our own.
Because then you have two language detections. You have one for the speech, and then you have one for the text. And
but we don't have one for the speech.
No, it's only
that's one when you send it to Whisper. Or do you put the language tag with it that it's always Swedish when you send it to Whisper? Otherwise, it's always a language detection first in the architecture for Whisper.
When we're doing with the Azure, we send which language it is.
Yes, but we don't have to. You can send. You don't have to send language. You can have like a flag that's language detect set to true, and then you don't have to send
exactly, but then it does language detection within the Whisper model. I have so many questions. When just one
it's
final
really
thing.
wonderful, excellent questions, and we're really grateful.
Very quick one is just that you don't do the decibel level for silence detection. You use a VAD model, voice activity detection, instead of decibel level. That's it. Okay. Thank you.
Yeah, thank you, Jonas. Yeah, I really appreciate all your wonderful questions, and I'm sure the team will be here. If you have questions, you can ask them afterwards as well. And that goes for you also, Jonas, if you want to continue your Q&A. But that being said, give them a warm hand and thank you very much.
So yeah, we're obviously going to talk about the Swedish Sea Rescue Society. We could first introduce ourselves, I guess. So I'm Philip. I've been studying economics and math, and I'm starting a machine learning master next week. And you can introduce yourself.
Yeah, so my name is Axel. I study industrial engineering at Leo with a master's in applied mathematics.
And then I'm Theo, and I also study the industrial engineering, but I do that in Lund. So that's the team.
Perfect. And today we're going to quickly go through the background, a little bit about the data, as well what type of models we've used, and the GPS interference. We'll get to that, and also what's next. So a little bit about the background. So the Swedish Sea Rescue Society is obviously a non-profit, but being non-profit, they're very forward-thinking, they're very innovative, they have great knowledge within their organization. For instance, they produce their own boats, and the boats have, the best technology there is out there. For instance, they're currently, so part-time, we're sitting at the AI office, but also sitting at their local office, and they have just outside the building this big launch pad for drones. So they're, always doing what they can do. And currently in their engines, they have a lot of sensors.
they collect several different engine values, but also geographical values such as longitude, latitude, speed, etc. They currently want to explore what there is with AI, what can be done, what's available right now. And with this scope, with the resources they have, the time we have found two main areas within the project. So the first one is to model the engines. Being within the organization, of course, you're going to have to save people. They're going out on missions, and it's critical that the engines doesn't fail when doing that. Is it possible then to look at the trends for the data? Could the data tell us that before an engine failure, there's certain deviations? And we're currently, or for this project, we were looking at the Victoria class 12-meter boats with the D8 Volvo Penta. It's their top of the line, almost newest type of model. And the other part of the project is GPS interference. So especially in the Baltics recently, there's been a lot of issues with GPS interference. And when they're on auto missions for the safety of the crew members, but also the rescuees, it's important that they can navigate correctly. So we're trying to look into the data if there's a lot of volatile behavior within the GPS data. So within the engine data, we have RPM, it's revolutions per minute. It's how fast the motor is spinning. We have oil pressure, which is how the pressure within the oil into the motor. We have fuel rate, how much fuel is consumed. We have the engine hours, the how old an engine is. We have the load and the engine temperature, and also longitude, latitude. COG is compass over ground, so it's the direction. We have speed over ground, how fast it's going in knots. We have also made some API calls to SMHI to get the right wind direction of a wind velocity, as we are assuming it's very important in the context. And to understand the data, we're doing a bunch of initial exploring. First of all, the data comes pretty unstructured. Different measurements are taken at different timestamps. We were also very interested to see how they interrelate. And you can see on the graph above that most of the engine data has a very linear relationship, except for engine temperature, as you can see below. It has to heat up before it stabilizes. And just looking through the engine data, there's difficult to identify anomalies right away. And that's the issue. Like, we're trying to find malfunction engines. If there's no documentation of anomalies, there's really no anomalies within the data. We didn't really know how to approach this. So we spent a lot of time becoming detectives. We were looking through a lot of old invoices to see which boats has been newly replaced with which parts. The thing is, none of the invoices necessarily tell to which boat they were directed towards, or neither during which date the boat was repaired. Most of the invoices were also minor fixes, such as replace an oil filter, standard type of stuff. So that caused an issue. We did find some major stuff. However, those were before data collection or the sensors were implemented into the engines. We were also calling a lot of local stations asking, has any boat, been struggling? Have you done any service on it? We also called the service technicians, but it was very difficult to find anomalies.
Yes, but even though it was difficult to find any clear anomalies, we did decide to do, or because of that, we did decide to go down the path of unsupervised learning, since we did have a lot of data of normal activities from the boats. So we started exploring different models. And in that research, we were at first just diving into case studies and doing a lot of research there. Then we started, interviewing and just having conversations with our AI Sweden colleagues in the Gothenburg office. And we got some great help there from people with domain expertise in machine learning. And then also from a different talent group, actually, who were working with cybersecurity for vessel navigation for the Swedish defense. So valuable intel from them. And then we also managed to get an interview with the engine manufacturer. So like Philip mentioned earlier, this was Volvo Penta engines. And we managed to get an interview with Peter Gerhardt. He gets a shout out because he's VP services at Volvo Penta. So he was really in the midst and knowing how they work with predictive maintenance for the engines. And we got some insight into what they're doing right now for that as well. So we initiated a collaboration together with them, but more on that later. But the model of choice in the end was the LSTM autoencoder. So as you can see, we did try a few different ones, so isolation forest and normal autoencoder. But in the end, we did decide on the LSTM since it allowed us to capture the temporal dependencies. So we have the time series data, and it's important for us to be able to create sequences because we're looking at boat trips. And a boat will be the boat trip or the features will look very differently depending on if we're in the beginning of a trip or in the middle or in the end. So it will look different, like if for example, like we saw before, if the engine is heating up in the beginning of a trip. So we sequenced into trips. And that was because we also found it to have a strong performance, the LSTM autoencoder in our test, and then also in the research literature that we were looking at. So this is what it looked like when we were trying the isolation forest. So we decided to not pursue that route. But then more on our model then instead. So this is quite a beefy slide, but we will walk it through to make sure everybody understands it. So we started with masking in this first layer, and that is because we have varying trip lengths in all of the boat trips. So we use masking just to make sure that all of we use padding rather, to just make sure that all of the sequences are the same length. And then when you feed the data into the model, then you use masking to ensure that only the data that's meaningful is being used by the model then. And then the second layer here, or the second part of it rather, I'd say, is filled with the encoder. So the encoder takes the sequence that we put inside and then inputs it into a higher dimensional space. And that allows us to find more complex patterns. And so that processes the entire sequence. And then when we move into the third level of it, it then compresses everything into a single vector. So the vector gets sent into the third level here, the repeat vector. And what the repeat vector will do is that it will repeat this single vector for as long as we have set the sequence size. So let's say a boat trip is 100 time steps. Then it will repeat this vector 100 times. So you will have a sequence of 100 time steps. And then that compressed vector, or sequence rather, is being sent down to the fourth level, which is the decoder. And the decoder will be able to process the sequence and then transform it with all the information that's compressed within this vector, and then basically unpack it. So we can still keep this temporal dependencies that we had from before, and basically start getting ready to reconstruct the trip. So I will show you this to make it a bit more clear, because that was a lot of words, but now we'll try and visualize it for you. So at first here, if we have the dark blue, that's the input sequence. So we put in a sequence of, okay, this is real data from a boat, and we can see it on the graph. And then after passing through our model, our output sequence that was outputted is the light blue one. So it has taken this first sequence as the input, and then it has reconstructed it. So as you can see, it's fairly similar as well. So it's one of the reasons why we decided to go with this model in particular, or this type of model in particular, because we could see that it did perform really well. And then a little bit about our training infrastructure as well. So it was quite demanding for our local PCs to be able to train this model as we were building it. So it's trained on over 2 million parameters. And you can see the infrastructure for it right here. So we collect the data from the InfluxDB, that's the Swedish Sea Rescue Society data. And then we have the SMHI, like we mentioned before. That's where we collect the weather data from, which we connect to the boat data. And then, as we can see down there, we did decide to, we did have to create a Docker container where we put our scripts into. And the reason why we had to do that is because since we weren't able to train the model locally, we needed more computing power. So we reached out to people at AI Sweden, our colleagues, and they helped to set us up on the IQ platform. So we got some great help by the Axia staff, and we were able to, be much more productive in how we experiment with the model, because we could now really change things up and then tune the model, etc. So in the end, we ended up with an LSTM autoencoder, which is then our model. And here's a demo of how this of our dashboard, of the dashboard of the engine model. So the user will first go into show overview, which will then print out all of the different, or like rather visualize a heat map of the anomalies for all of the different features. And this is a scale. So if there were no problems whatsoever, we would have an entire white heat map. So as you can see here, it's rather okay, but we're going to see later how it looks for an even better boat. So this is a boat that might have a few problems. And then if we continue. Yeah, as we see, if you hover over it as well, we will have additional information. So it can be detected by the technician, which boat this is and for what date and what trip. So if we pause here, this is the single incident that we received from the SSRS where we actually knew a boat that had gone into service. So we could, it wasn't a clear anomaly. It's not like it malfunctioned in any way, but we were able to see some difference here in before and after it went into service. So the bigger spread here means that we have a larger error or a larger loss. Then again, this was the single instance where we were able to look at this. So we couldn't guarantee it. We couldn't guarantee that or reproduce the results. But we were able to show this and discuss it together with the SSRS. And they were very pleased that it did entail that there's something here to analyze. So we can continue to run through the rest of the demo as well. So it's able to zoom in as well. And this is mainly a tool then for the technicians to simply be able to go onto the app and look at the boat trips, and then go in more into detail of what's wrong. And then when we go down here, we see that it will also highlight the comparisons between the port and the starboard, which is also important because there are two engines on the boats. And even though if the features themselves look okay, there might be discrepancies in the values for the two different motors, which would also entail an anomaly. So this is all very clear for the technicians to see here as well. All right.
I think we should go back and show the scatter plot to see.
All right, so we can show the scatter plot. Which one were you thinking about?
The one with the service. So go back a little bit. This one. So this is basically showing the same thing as in the heat map. Instead of showing like a cumulative value for the day, it's showing each individual points for each trip. And what we're talking about is this is before service. Here they went into service. You can see how it goes down. Doesn't necessarily mean anything, but it's at least something, an indication of what it could be if they were to spend more energy or more time into gathering the data that's needed. So that's very interesting.
And compared to the other boats, as we can see here, for example, this is when we selected the other boat, Amalia Wallenberg, and you can see just a straight pattern. So there's no difference in the spread between the losses. Okay, and moving forward.
All right, so then we move on to the GPS interference that they wanted us to take a look at. And GPS interference, well, the background is that some unnamed country has increased their GPS spoofing and jamming in the Baltic Sea. And then just GPS jamming is simply blocking or jamming the signals, so you can't get a signal. And then spoofing is tricking the GPS or the navigation system into thinking that you're in a place where you're actually not. So it's tricking your navigation systems. And of course, this would be a problem for SSRS since if you're out on a mission, you really want to know, is my location accurate? Is their location accurate as well? And we won't be able to solve this problem, but we can at least alert them before they go out on a mission, whether they can rely on their navigation systems or whether they should take a closer look at their charts and do it the old-fashioned way. So the data we used for making this model is latitude, longitude, compass, speed of ground, the cell strength, and the RPM. So to see if the boat is running or if it's stationary in a harbor. So the solution is a 3-part system. I'll show it on the next slide. But you can check the GPS accuracy every hour, and it automatically updates. Or you can take a look at a past incident or a past date. And then you can also aggregate the results over 24 hours to see, yesterday, were there any disruptions or were there any faults? So this is what the GPS disruptions page look like. You can pick a date and a time. And if you press, I was a bit slow recording this, but if you press update date, you'll see you get a map here. And this is just arbitrary results, but the yellow is where one boat has reported an issue. And the red part is where 2 boats, at least in the same polygon, has reported an issue. So here you can see that there are quite a lot of boats reporting issues.
Maybe we should just also add that if we have the 2 boats, that entails that if 2 boats in the same area has seen errors, then that would be more indicative of a interference. Whereas if it's simply 1 boat, it's more indicative of, this might be a sensor failure. But if it's sensor failures on 2 boats at once, then even if it is an interference, it's something that the technicians will want to take a look at. Yes.
Yeah, and then to have some additional explainability of for the model. No, we lost it. But we display the max speed, the total distance traveled during that hour, and the maximum distance from the median point. So sometimes when they completely lose signals, they go to the coordinate 0, 0. So they go to outside of Africa. And you'll know that either there was a faulty sensor or you couldn't get a connection, which both could be interesting things to look at. On the boats here, you see there are really no issues. This is just arbitrary data. Then if you display an aggregated map, you'll see, all right, so this was the past 24 hours. We collect all the polygons and then we display a new map. So you can see the colors. So red is if there had been more than 2. Maybe we should increase that, but right now is if there had been more than 2 in 24 hours. Let's see. And then I should move to...
Could also add that something that we found strange from the beginning is that we see these polygons over inland Sweden as well. But it's actually that in these lakes, the Sea Rescue Society does have boats in the biggest lakes in the country, and also 1 boat up there in Norway as well. So this is only feeding from boats that are active right now.
So if you press now, you get the past hours results. So you can see if there had been any interference within the past 24 hours. It takes a bit of time to load since the model has to do some inference, but we'll see here in a second that it will display a completely green map. So everything's fine at the moment, or at least it was a couple of days ago when we recorded this. So under the hood, what it does is you get your 3 buttons. They have 3 different scripts. So you check the need if there's a need to create the map, or if you want to display an old map, you take the date and the time. We take it to, or we make a database query, and we either create a map after doing some inference, or we just display a previously made map. So the process of working with this was, we looked for GPS disruptions on, there's a site called gpsjam.org, which looks at GPS disruptions from plane navigation systems. So we took a look at that, matched dates with dates where SSRS vessels looked to behaving a bit weird. then we began data labeling. So labeling some trips anomalies and labeling some trips as regular trips. Now this was a very time consuming and quite boring task. But we had to make sure that the labels were set correct for each boat, because you don't want anomalies in normal data and you don't want normal data in the anomalies. So we had to display all the trips 15 minutes in 15-minute segments, because otherwise my computer broke. So it took quite a lot of time, but once we had that, we tried just doing supervised learning with that. We didn't get that great of a result, to be honest. So we took a look at some research reports, and if you don't want to label any more data, you can do some semi-supervised learning. So we trained an LSTM autoencoder like the previous one for engine modeling, a bit smaller this time though. And then we fine-tuned it to perform binary classification. So we froze some layers of the model and removed the last layer of the model and added the binary classification instead. And some future improvements to this system is, well, of course, to make the site less buggy. Right now, you have to select the date or time twice, because it just writes it over the first time. Fix the colors on the aggregate map. And then some long-term improvements is Jonas, who contact from SSRS. He talked about adding GPS sensors on each station house, so you can see where the boats are located. So you can see if there's... So you have another point of validation, in a sense, that should always stay at a specific location. And then include flight navigational data as well. The GPS Jam site is made only with flight navigational data. Including that will help increase the coverage and also increase the accuracy, hopefully.
Yes, so the next steps now is that we will also be working these 5 days additional together with the SSRS. So we're working on the proper handover of code with the documentation to SSRS and their external IT provider. And then we're also looking into see how they can ensure capability to gather this anomaly data in the future. Because like we mentioned previously, we did start collaborating with Volvo Penta. And they are also they're not that far along in working with predictive maintenance of their boat engines, but Volvo in general is, so for trucks, for example. So they are they're in the theory stage of implementing it in Volvo Penta right now. And they also had quite a fair bit of data, even regarding anomalies, that they were quite open to sharing as well. So that's quite the promising collaboration together with them. And if we do get that anomaly data, then it would be easier to test model further and take it even further than it is now. And then we had some final words. And first of all, we wanted to say that since we were the only team in Gothenburg, we did miss you guys, the other project groups, but we also wanted to give a special shout out to the teams or the colleagues at the Gothenburg office as well, because even though we were quite alone in the beginning, they were all super helpful and also just fun to be around. So they made it a great summer. And that's, I don't want to mention any names because I'll forget people. But yes, shout out to them. And if you guys have any words as well.
Also shout out to Ixia, who helps us a lot with the IQ systems. We broke it a few times.
Nothing bad.
No.
Yeah. And that's it from us. So thank you very much.
Thank you.
Okay. I think we can all fit here somehow.
Yes.
Yeah, thank you for a really inspiring presentation, and super impressed to see everything that you were able to achieve, although you didn't have such a great history of like breakdowns in the data, basically. But with that being said, I do want to open up the room also for questions. So please raise your hand if you have a question for the team here. Yeah.
I was just wondering, because it was not clear for me. There you go. I was just wondering, because I was not very clear, the dashboard that you showed, have you deployed that, or is it like a standalone app?
No, it's deployed.
It's deployed?
Yeah.
Okay, cool.
It's streamlit.
Yeah, so it's very accessible. Easy deployment. Yeah.
And Yeah, well, I think you said it at the end that you're still not sure about, or you're still working on the handover of the documentation of the cards. Have you already talked though about it, and how do you see, are they going to be using it? Have you talked about that?
So I don't know if we can go back to we have a small here, down here. You can see it's a snapshot of their platform. So the idea is to integrate our current implementation to their platform. But that's because their platform is from a third party. So we're gonna do documentations for the third party so they can read through, see how we've been thinking and all the components of it. And then they will do the implementation themselves.
And even though we haven't had the final presentation together with the entire office in SSRS, the project lead from their side, we've had meetings with, and we've showed the finalized product and everything as well. And it's what they want. Yeah, it's what they want to integrate into what they already have, and it's what they were looking for, just to see if they could analyze the data and see, like, is there something there? Like, is there a nugget of information that we can use? So yeah.
Well, thanks for answering. Cool project.
Yeah, thank you. Really good project. One thing that I thought about was as the Sea Rescue Society is dependent on volunteers running these vessels. Have you had any conversations with the organization on how to report when an engine breaks to better improve the data coming into the system?
So we have, but the main thing now is that it should just be reported from the local station, because right now the local station, they know what happens to the boats, but it's not really being forwarded to the headquarters, which is why we had to call out all the local stations as well. And they are super busy with being operative, so operational. So when they sign up to be volunteers, they just want to go out onto the boats. They do not want to do these things. That was very clear from SSRS and from Jonas, our project lead. So we haven't looked into something automated, but it seems like that's the way forward, because they don't really want to put more administrative burden on the volunteers, but not something that we have looked at just now.
Great, thank you.
All right, any more questions? If not, I have one final one. So tell me a little bit about when you were doing this detective work, right? In order to find out things and information about the data. Talk me a little bit through that. Like, how was it? Did people in general understand the concepts of like AI and predictive analytics, what you were trying to do, or was it completely like confusing to them?
I think there was a lot of inertia to begin with. Once we showed up the first couple of times to the office, they were like, who are these people? You know, we have big screens of code, and you know, most of them are doing like economics. So there was a lot of inertia at first, and we started asking, but also showing up, talking to the people, explaining what we were doing. Then, you know, the inertia slowly dissipated, and eventually they were more than happy to help us with whatever, you know, we wanted. I think we received more invoices than we needed in the end.
Yeah, and I mean, the economics department is probably, or the finance department is probably not that happy to see us always, because they have to go digging for stuff when we're there. But they're super happy to help. So it's been great to really be there working with them as well.
Great job. Thank you so much for the presentation. Give them a hand.
All right, welcome to our presentation. We're super excited to share our work with you guys, and I guess give our development lifecycle through this summer. But before then, who are we? I'm Finn.
I'm Markus.
I'm Elise.
We are the Uppsala gang. I hope that's appropriate. That's just what we call ourselves. And we're all master's students from Uppsala, and we study data science there. There's 2 tracks, data engineering and machine learning and statistics. So all 3 of us found this program, applied together, and feel really lucky to be here. And who's our client? Oh, this is not changing again. Back. Okay, there we go. So sorry. Anyway, so who is Mind? Lisa, super glad to see you. Mind is a nonprofit dedicated to providing mental health awareness and suicide prevention. So they have chat agents as well as people available to call if you're in need of help. What about our project though? Markus?
There's
a lot of new research going on about the suicide prevention and mental health, and also but in the mind organizations, not all the volunteers or not everyone they are not all of them are academic experts in the field of suicide prevention, and the goal the first brief was to implement a tool which can summarize and make the research, the newest research, more understandable and also more accessible to all of the volunteers, with an easier platform for the not only the organization mind, but also for the whole network and maybe also other organizations. And that's why we came up with we decided to use a tool RAG. This is called retrieval augmented regeneration. It is a bit similar to like a chat service, but with a difference that we only have one question and one answer, and it can also use private data from documents or from some other online tools as the input to also use more interesting data.
So from the beginning, we had a repository basically of publications that Lisa had given to us that were specific to or relevant to their organization. So this was a solution that we identified from the beginning as might be helpful for understanding those same publications. Moving on.
Yes, and then we built our first prototype. So the idea was that the user should upload the research articles, ask a query about them, and then of course generate an answer or get an answer to it. But we quickly identified some new functions that needed to be in place to use it even more. So that enhanced our work going forward.
Yeah. So for that first prototype, we were playing around with a lot of different embedding models, as well as different language models, just locally and trying to move quickly so we could identify problems early on. One of the problems is that very thing is there's a bunch of different embedding models and LLMs to choose from. So how do we optimize that for the best results? Another problem was manually sourcing research articles maybe isn't very good for the survivability of the application. So additionally, adding other resources would be helpful. We also ran into the problem of language. So for example, the research articles are in English and you prompt it in Swedish. And even if you preamble and tell everything you can, like you're gonna get fired if you don't speak Swedish, it would still sometimes switch to English because all the documents it was receiving were in English. So we were talking about trying to figure out how to do that. And additionally, we had problems with narrative text. Basically, some of the retrieved documents would include tables or citations that just don't really make sense to the user. That was something Lisa identified early on as well. So our solutions to this were consult experts. Lukas, big shout out, and Jonas, you're still here. We got to meet with them and ask about these problems we were having. And we got some really sound advice just overall about where to focus our energies. For manually sourcing articles, we also added connectors to different database archives, basically publication resources that are on the internet. For language, we got the advice to just choose a base language. And so we switched that to English. Research articles were in English. And then for narrative text, Marcus came up with a really cool solution to this that I'm going to leave to him to talk a little bit more about.
We use our own classification algorithm, which can classify the text chunks if they have a content which we're actually interested in, or more like reference, or like some different nodes which you don't want to have as input in our LLM. And that's why I use a bag of words with a neural network that could get a very good accuracy of more than 99%. And that could filter out a very good way all the information we didn't want to use.
Yeah, and so this solved a huge problem for us. Also, just side note, I know we didn't talk about this, but Marcus, when he trained this, it was kind of like one of those days. Lisa and I were working on deploying the application for the first time, and had just been like staring at our computers for, I don't know, 4 hours. Yeah. Like, Marcus, what did you do today? And he was like, oh, I fixed the classification thing. And we just had perfect narrative text chunks for the retrieval part. So that was a really awesome addition to the project, and it solved a huge problem for us.
that's what we use for our first version, which we also tested later to the researchers. We call it a knowledge seeker. It includes a search bar in the middle where you can write your question and also a welcome tool if you are new on the website, and then you can decide which search tool you want to choose. For example, you could choose saved files first you have to upload a document for it, or many documents, and then you can enable it save files in the settings, for example, or you can also use some archives such as archive for different ones. And then you can type a question, and after you hit enter, you get a nice answer, and also some of the text you can click on, and then you get the citations of it, text chunks, and if you click more, then you see the full text chunks where the information is coming from. And also the documents are also saved, or like at least the text chunks all of them are saved on the website. But you can find out where it's coming from.
Yeah, so we built this first version, and we can build stuff, but we're not expert within the research area. So we wanted to meet with some researchers, and Mind has a huge network with also like the top researchers within mental health. So we met with 4 of them, and we got some quite interesting feedback. For instance, also like a new use case, and you will see that throughout the quotes. And the quotes are in Swedish. I'm going to translate for you guys. So this is from Walter, and he says, throughout a very good answer to my questions, very promising application. It's going to be interesting to take part of the function concerning to find new research areas. So here he identified like his own usage of the application. That was really fun to see. And he believes it's going to, and he believes it's going to be a really valuable service for the users of Mind on the webpage. And he also works with ChatGPT 4.0, and he really appreciates that we have some references in there. So that was fun. And here we met with Bo, and he really like prompted the application, or like asked all queries to the application. And one question, this one was a little bit more abstract, but regardless of that, the answer was still good from his point of view, and he's like the top expert within mental health. So that was really reassuring to see as well. And he said a similar thing as Walter. So he also believes it's going to be a very valuable application for Mind, both for like your internal personnel, but also for the volunteers. But again, also for the researchers. But that was really fun to see. Yes. And also from Mind as well. So Lisa, you also tested the application as well. And you also got correct answers to your questions. And you agree, correct me if I'm wrong, but you said this in an email, that you agree with that it's quite interesting to see where research is missing, and perhaps Mind can also engage the research community to pursue those areas and further get more knowledge and create impact.
Okay, so we have a live demo for you guys, but before then I want to talk about some of the other key features that Lisa pointed out to us and requested upon seeing version 1. And that included something called lookouts. So I'm just going to pull this up first and we can demo everything that we've talked about. Also, this is running on localhost right now. The version 1 is still on Google Cloud Platform, but we were doing updates last night still. But welcome to the UI. Just to give you an overview, so we have this composer in the middle, and this is where you can ask research questions or search for things. In here, you can select the different data sources that we have. So save files is like that normal classical RAG, which sources from only the documents that you choose to upload into the system. We also have arXiv, which is another research database, PubMed, and clinical trials. So you can turn these on and off here, but you can also turn them on in settings. So this is from the screenshot. This hasn't changed too much from the version 1. But for example, if we turn on clinical trials, and I have something pasted from over here that I want to copy over.
and we want to see what results come from a really simple search. So research on cleft lip palate. Press enter. And so what's happening right now is it's submitting that request and fetching the relevant documents, and then it gives those to the LLM to contextualize into a response depending on what you say. So if you ask for research, it will search things, and sometimes if it can't find enough like quality results, then it'll do extra searches, or if you have multiple tools on, it'll try and use those. But this is the result. And so some improvements from version 1 that I want to highlight is like automatic sourcing. Like you can see the reference list here just as it is, but then you can also go into that resource or that I guess
Research article?
yeah, exactly, where it came from. So you can see these, and then also if we click in on one of these, then you can see that it highlights that specific citation. If you click see more, you can see the whole chunk, or the whole document that was basically given to the LLM. You can also still click into the original source. And yeah, so this is just the user interface for search. And if we come back to the main files or the presentation thing, we can see this is where you upload files. We've uploaded a couple from Boo, who was one of the researchers giving us feedback. And so this is his research. One of the questions he asked, I think we have time to do it. So this is kind of one of the things that he asked. And because we have his research uploaded, if we don't want clinical trials as the data fetching resource, we want the save files. And if we press enter, and we get the response. And I guess if you read through these or get the chance to play with the application, we think it's pretty high quality. But Lisa, you'll be the final judge. And then this last feature. So you'll notice we added this whole bottom half to the screen. This is called lookouts. One of the things that Lisa identified that would be most helpful to her and their organization is the ability to basically watch or subscribe to different research topics and then automate basically this process. It would make it so you don't have to come in and say, if you want to do research, enter a query and I guess do all of this manually every day, every time you want to get new information. So how this works is you can create what we call a lookout to look out for new research. And we have one just built in right here. But if we want to add a new one, so say you can name it whatever you want to keep it organized. We're just going to call this test for AI presentation. And then what condition or disease do you guys want to look out for? Anyone? Depression. And you can filter the maximum number of results, the location. I'm not going to do that because also some of it's buggy. It's okay. We'll leave it. And so then here it is. And as you add these, it will scroll to the right. But we can see all of just the publications that have come from the data source. And the only one that we've hooked up is clinical trials because they had an official API. And then to illustrate, basically, we have a cron process that will trigger an endpoint weekly to run this process, check what we have in the database for publications, say, hey, what's new? And if there are new ones, send it to my email. That takes a while to run and I have to trigger it manually. So we just have a email that came from that right here that at least forwarded me this morning. So this is a lookout that we had up, and you can see the AI summary. We aren't doing any pretty HTML email formatting, but this is basically what the AI is saying about the documents, and ideally these are all new to you. But yeah, so that concludes the demo. Is there anything else?
No, I think that was it.
Okay. come back here. And Elise is going to talk about that distribution platform that we're using for the emails.
Yeah, so we sent out that email on like with all of the new research. And we did that by enabling like a webhook being sent from our platform. A webhook is like a reverse API. So instead of asking for data, you're just giving data and then somebody's listening to it. So somebody's listening on this public URL where we're parsing the data. And that someone is an automation tool. And through that automation tool, we have enabled that email to be sent out with parsing the data throughout the automation flow. But you could also connect it to MailChimp, for instance, and send it directly to volunteers or internal partners. You could send it to Salesforce. You can send it to Facebook ads if you wanted to. You can send it to 7,000 applications. So with that, we hope that we have future-proofed whatever distribution Mind wants to have and save time with that as well. And yes, future improvements. You can always work on design and also user experience. So it would be nice to do even more of that as well to make it even more intuitive. But yeah, that's what we managed, and we're quite happy with it.
And of course, there are also more sources for different research papers. For example, the most popular one is Google Scholar. But we also thought about it before, but it's also more challenging because Google is quite restrictive with their API and their scraping, but also like other official research papers or different information tools, such as Wikipedia.
Yeah. And of course, a giant future improvement that was also identified from the beginning is that multilingual support. We just didn't have time to fix the problems that we were creating with it. But that's something that would be remarkable for, I think, the application's usage and accessibility, and also support for organizations. So like we've tried to kind of design this application so that it's agnostic enough that other organizations could use it, even if it's not in, I guess, the mental health awareness and depression, suicide prevention space. But within the UI and the design, adding organization level like files and stuff like that, I think could also be really helpful. Our reflections, we'll keep this short. We feel really lucky to have been a part of the AI for Impact program, and we've learned a ton about implementing AI like as a tool. And we feel especially lucky to have worked with Lisa and Mind, actually making something that's just for the good of humanity. And so that's felt really good. And additionally, on a more technical standpoint, something the three of us learned in our data engineering courses was to focus on choosing the right tool for the job. And we also, I think, received similar advice from Lukas and Jonas. And I think that is one of the big takeaways for us, is like we wouldn't have gotten as far as we would if we hadn't chosen the right tools, and we could maybe get further if we'd known more. But at least.
Yeah, so thank you a lot for this summer. It's been great being here and working with both Mind and with ASWID and then the rest of the student teams. We've been having a blast, and we've been writing code and also baking bread, so it's been a great mix of that. So thank you for that.
Thank you so much. If we will update the site on my AI soon, or if you want to add us on LinkedIn.
Yeah.
Well, thank you so much for a very impressive and inspiring presentation. I had a quick question about this text, the classifier thing. So just remind me about like the reason for that. Is it to be able to filter out some irrelevant text, or is it maybe to like detect like references, or if you can just remind me?
It was mostly important because in the beginning when we did similarity search for the rec, sometimes we got references or like text, like very small text chunks which are very short and contained were like references, for example, from like researchers, because there are a lot of references quite often in the papers. We wanted to filter them out.
Right. Yeah, very clever solution to that. Gonna invite the room to ask questions as well.
I can not ask a question, but I just want to say super much thank you to you guys. It's been a privilege to work with you, and I'm super proud. I feel like a proud parent in the last Just very, very much thank you to you guys.
Thank you.
Thank you.
Thanks. Big applause once again. Thank you.